Hi guys! I think I start every single video saying hello to myself and pretending it's everybody but me. So, we're getting there, right? We're running out of steam. Getting tough. I'm listening to my squeaky dog. Anyway, we are starting a new chapter today with this recording, and it's a really short chapter in your book, but it's one of my favorite. So I'm looking forward to it. I'd say I'm prepared. I'm prepared and I'm not prepared. But it's kind of how the world is right now. So we're going to get going. I'm looking down because I'm trying to get all my notes out that I forgot to get out ahead of time. And we got to do things like all these crazy pictures that I just redraw a million times. So we, at this point, you've taken the 5th exam. It was untimed. Hopefully that worked out for everybody. And you're ready to do this last few chapters of the semester. All right, so we're doing chapter 15. This is lecture 1, and 15 is about the autonomic nervous system. And I'm going to tell you that's where all the money is. That was what my high-paying job had to do with, actually, and what a lot of pharmaceuticals have to do with is aspects of this chapter. So I'm going to be honest, we're going to get a little technical. I'm sorry, but I still go there every year. So it's nothing personal. You can handle it or you can't, but we're going to try and do the best that we can do. So let's get started. And I think I'm going to start not being so ginormous, being little in the window, because I hear that you guys like that. Maybe I'll even lower you a little bit. And there we go. Let's just refresh our memory about the nervous system organization. So I'm trying to, all right, organization of the nervous system. This I'm just kind of pulling out. I don't totally have it. So you have the central nervous system, right? This is all stuff from a previous chapter. And that consists of the brain and spinal cord. Right? So it goes to this guy, and then it goes to the peripheral nervous system. How about I spell that right? Oh, sucker. Let's see. Peripheral nervous system. And with the peripheral nervous system, they interact, right? They communicate back and forth with each other. The peripheral nervous system has like inputs, which is the sensory aspect. And sensory is the general senses and the special senses, right? Vision is a special sense. Touch is a general sense. And then we have the output part. And the output is the motor division. And the motor has the somatic division. I can't write that. And somatic division talk to skeletal muscle. And then it had the autonomic division. I'm just going to put it there. And the autonomic was there's actually 3 branches. Because I'm out of room here. Autonomic. Everybody seems to be able to write pretty good on these, except for me. And the autonomic consisted of the enteric nervous system, the parasympathetic, and the sympathetic divisions. So this chapter that we're doing talks about these parasympathetic and sympathetic divisions of the autonomic nervous system. And the first thing that we're going to do is kind of start with what we know, because we talked about skeletal muscle and how that got activated with a motor neuron at the neuromuscular junction and that sort of stuff. So we're going to talk about kind of the somatic motor neuron and how, go from there and start the autonomic nervous system. Okay, so it's super bright in here, so I have a hard time seeing the cursor. So let's start right here. Okay, so the peripheral nervous system is everything other than the brain and spinal cord, so it's all those nerves, and it's incoming nerves and outgoing nerves. So we actually have, these are subdivisions of the motor division, the output. And we have the somatic, which talks to skeletal muscle, and then the autonomic. And the autonomic talks to different parts of the body. It talks to smooth muscle, cardiac muscle, and glands. And glands make hormones. All right, that's the deal with glands. So, and then the enteric, and the enteric has to do with gastrointestinal. That's GI, gastrointestinal, so that has to do with like the digestive system. The brain gut, the gut brain, whatever. I hate talking about that one, it's boring. Okay, but the autonomic nervous system is not boring. So the autonomic nervous system has the motor neurons that, like we said, are talking to smooth muscle, cardiac muscle, and glands, and you're not aware of what they're doing. So it's involuntary. And I'll never say it's the general visceral motor system. That sounds horrible. All right, so let's start with a somatic neuron. All right, and I just flipped from the page that talked about all the words, and we'll go back to that in a second. I'm just trying to find my pen. Okay, so here I have the spinal cord, and the spinal cord is the central nervous system, and I will have one motor neuron, right? This is just one motor neuron coming off of the central nervous system that goes to the effector, and the effector is skeletal muscle. This motor neuron will always release acetylcholine. Acetylcholine is my neurotransmitter. And this motor neuron is heavily myelinated. All right, so that's what we're used to seeing. One motor neuron coming from the central nervous system going all the way to the skeletal muscle. It has a whole lot of myelin on it, and its neurotransmitter is acetylcholine, and it will always turn it on. It will always excite. It's an excitatory response. So when that skeletal muscle gets the acetylcholine message, it will activate it, right? Activate the muscle. Okay, so let's go back here. Somatic neurons. Oh, here's what we were talking about, that there's, when it comes to motor neurons, there's only one, goes to skeletal muscle. We control it. That's true. It's voluntary because we like to move, and the response is always excitatory, and the neurotransmitter is acetylcholine. When we talk about the autonomic nervous system, just in comparison to the somatic, all right, we're not going to go into the specifics of parasympathetic versus sympathetic, but one thing is that it's a two motor neuron chain. Okay, so there's one coming off the spinal cord, and then there's what talks to another, which then goes to the effector. So I have guy number 1 and I have guy number 2. Yeah, so I guess I should change this to like an A because I just numbered that. B. Oops. They're either lightly myelinated or there's no myelin. Or no myelin. 3, C. My effectors are cardiac muscle, smooth muscle, and glands. We'll just say glands, cardiac muscle, and smooth muscle. D, my neurotransmitter, I'm just going to say NT, is sometimes it's acetylcholine, other times it's going to be norepinephrine. Okay, norepinephrine is the same thing as noradrenaline. And E, it will either, some cases it's excitatory and turns on, in other cases it's inhibitory. So it's either excitatory or inhibitory. Okay, I think, now we're going to come back to this and talk about other different specifics, but let's just make sure that autonomic motor, 2 synapses, so 2 neurons. My effectors are cardiac muscle, smooth muscle, and glands. It's involuntary, forgot to add that, and then it's either going to excite or inhibit with one of 2 neurotransmitters, acetylcholine or norepinephrine. So let's say D, it's involuntary. Oh no, D, E. How about F? How about I know my alphabet? F, it's involuntary. So if we're asking about a compare and contrast motor neurons of the autonomic nervous system versus a motor neuron of the somatic system, this would be a lot of the contrast, A through F. Oh, and then here we have it. Both have motor fibers. It was 1 in the somatic. I'll just say quantity 1, quantity 2 in the autonomic. And they differ in effectors. They differ in their pathway. We got to talk about this word ganglia. And the target organ responses means they're either going to turn you on or turn you off. 2 neurotransmitters, and my neurotransmitters could be acetylcholine or norepinephrine. Oh, look, it's going to spell it all out for us. Well, that's very nice. Effectors are skeletal muscle versus cardiac muscle, smooth muscle, and glands. The motor neuron in the somatic nervous system is thick, wide, group A fiber, very myelinated, going from the central nervous system all the way to the muscle. Autonomic nervous system has chain of 2 neurons. They're thin, lightly myelinated, or none. And let's see. Oh, all of them release acetylcholine, and the effect is always turning on, stimulatory, excitatory. That's the plus. In the autonomic nervous system, I'm going to be releasing norepinephrine or acetylcholine, and I'm either going to turn something on or turn something off. Just depends on who I'm talking to and how they're receiving the message. That's what we're going to leave it at that. And here's a table. Wow, like I'm saying the same thing 4 different ways. I think I'm pretty clear with that. And no, I don't want to talk about that right now. So this is just another kind of picture of the somatic versus the autonomic. So somatic, 1 neuron, heavily myelinated, releases acetylcholine, talks to skeletal muscle, and is always stimulatory. Okay, I feel like I'm beating a dead horse. In the autonomic nervous system, it's 2 neurons. I actually don't want to draw on this because I'm going to be drawing on it in a minute. They're either releasing acetylcholine or norepinephrine. They're talking to different effectors, and they're either going to be turning it on or turning it off. So that's kind of funny. Let's just take a little peek here. And then we go into the autonomic. Okay. Alrighty. I'm just seeing if I want to say anything else. I don't think I do. I know I jump all over the place on you guys. Sometimes you must be like, stop. Alright, well, I guess we're going to stop there with this this talk. Just stop talking with the concept of the fact that we talked about somatic, what its deal was, and how the autonomic is a little different. So our next lecture, we're going to really dive into the autonomic in a little more detail, because I should be a little bit further away, otherwise I'm in like this crazy band of sun. So I will see you for lecture 2. Bye, guys.